I don't know what just happened here. So I think I'll let you guys take Friday for a work day. You do what you need to do. I'm sure you have other classes where you have to work on papers and stuff and studying, and we're done with the material after the test, so I don't see that there's any need to meet. If you'd like, I can send you I'll send you a video that you can watch in place of class. All right, but let me begin with a word of prayer before I forget. Dear Heavenly Father, we thank you for this day again. I thank you for the break and time to relax and refresh, perhaps, and pray you help the students to just finish the semester well, just to complete the work they've started, and just to do their best, Lord, each day for your glory. In your name I pray, Lord Jesus. Amen. All right, so yeah, let's go through the solution to mission 3 here. We have a test when?
Wednesday.
Wednesday, yeah, so soon. And what's the test going to be on?
Mission 3.
Not all of mission 3.
Well, yeah, the good point. Most of the part of mission 3 which is fresh and new, not so much the part which is old news. I seem to have lost my laser, so I'll have to make do with this. But that's okay. So first of all, here's a function. Is it 1-to-1? Well, if we graph this, which is easy to do once you complete the square, because I can see that the vertex is at minus 2, 7. So it looks something like that. So it fails the horizontal line test, not 1-to-1. All right? So alternatively, you could have set f of a equals to f of b, and you would have been able to derive that a was not necessarily equal to b, right? Here's another one. 3x plus 1. Is this function 1-to-1? Well, this time I went algebraic. So algebraic, f of a equals to f of b. That gives me 3a plus 1 equals to 3b plus 1. Subtract 1 from both sides. Divide both sides by 3. We get a equals to b. So yes, f is a 1-to-1 function. Graphically, if you chose to do that part graphically, the equation is just what? Y equals f of x is just a line, and it obviously passes the horizontal line test as well. So you could have gone that way. Problem 75, you could have gone, I gave both arguments. On the one hand, the graph is like half of a sideways parabola like this. So yeah, it passes the horizontal line test, so it's a 1-to-1 function. Or, if you like, we can set the f of a equals f of b, square both sides, add 4 to both sides. Yay, it's 1-to-1 function. All right. Problem 76. Here we're supposed to calculate the inverse function and graph both the function and its inverse. So here I had y is equal to the square root of x minus 4. If I square both sides, I get y squared equals to x minus 4. What am I doing? When I try to find the inverse formula, I solve for x, right? And so I did that. It gave me y squared plus 4. But then I wanted the formula in terms of x, so I switched, y to x at the last step here. F inverse of x is x squared plus 4. Of course, I know how to graph this. This is a parabola which opens up, right, with y-intercept 4. Why do I only have the right half of it? Why is that? Isn't this a parabola? Doesn't it go both ways? So the reason that it doesn't go both ways here is that the domain for the inverse, right, is the range for the function. What's the range for the function? Well, the range for the function is 4 from 4 to infinity. So that means that the domain for the inverse, excuse me, I'm an idiot. The range for the function is what? 0 to infinity is, Michael is correcting me, good. And so since the range for the function is 0 to infinity, the domain for the inverse function 0 to infinity. So that's why I only have that half of it. And if you can, maybe you can see it, the one is the reflection of the other across the line y equals x, right? So for every point a comma b on the graph of the function, we have the point b comma a on the graph of the inverse function. Any questions? Yes, Michael.
Will the final exam be based mostly on mission 3?
The final exam is an amalgam of, it's a combination of like tests 1, 2, and 3. And I mean, I would say missions 1, 2, and 3 all are relevant to the final exam. Yeah.
Wow.
It's comprehensive. Yep. Otherwise, it would be kind of like ridiculous for me to replace test grades with final exam grade. But I think it's very reasonable because the final exam is a pretty complete representation of what we learn in this course. So if you do well on the final exam, that pretty much means that you have done well in your understanding of the material in this course, right? So I wouldn't say that the final exam is really easy. I wouldn't say that. And partly, not so much because it has harder material on it necessarily. It's really just, it has all the material, right? So it's harder to do everything well all at once, you know. So that's why, although I offer, you know, replacing the test grade with the final exam grade, I would say if it's helpful, because there are some of you who will do worse on the final than you've done on the tests. It just happens, right? But some do better. And typically speaking, about, I'm trying to remember, I think on the average, the overall class, like performance goes up about like 5% as a class. But for certain people, you go like 2 letter grades up from the final. So it varies. Some people it doesn't really help. Some people it helps a lot. Depends on the people. Any questions? Okay, so here we're given this function. We're supposed to find the formula for f inverse of y, and then we're supposed to find the range of the function. All right. So what do? I write down the formula and I solve for x, right? And that gave me 3y minus 7 over 2 plus y. Now that's the formula for the inverse function. Now, how do I figure out the range of the function? Well, I know that the range of the function is the domain of the inverse function. So it's easy to see what the domain of this is, right? It's y not equal to what? Y not equal to minus 2, right? So in other words, the range of f is just minus infinity to minus 2, not included, and then minus 2 not included to infinity. So there you go.
There. I changed the answer.
Okay, Michael, that's good. What if I was wrong and you were right to start with?
Uh-oh.
Uh-oh. Let's see here. Problem 78 here. Again, find the formula for the inverse function. So I write down y equals the formula, right? And then I subtract 3 to the other side. Do you guys understand this step I made here? I don't know if I've talked about this step too much, but it's a super useful step. I flipped it, right. So if you have 1 over a equals to 1 over b, you can trade that for just a equals to b. So you can literally take an equation and flip both sides. That's an allowed operation on equations. As long as a and b aren't both 0, in which case you're, of course, creating solutions which weren't there before, right? But anyway. So I flipped it, and then I solved for x, and that gave me x is equal to 7, what I got here? 7 over y minus 3 minus 2, that's my formula for f inverse of y. So there it is. Does that make sense? It's the same algorithm every time, right? Write down the formula, y equals f of x, solve for x. That is the formula for f inverse of y. When does this make sense? There's a case where this wouldn't make sense, right? If your function was not 1-to-1 and you tried to do this, it wouldn't work out. You'd get more than one solution or no solution at all. Problem 79. I'm like, oh, okay, well, if I'm solving 2 to the 3x plus 1 equals to 1, I can look at 1 as 2 to the 0, and then by the 1-to-1 property, I get 3x plus 1 equals to 0. Can anybody, if you didn't see to do that problem that way, what's another way we could have done this problem, problem 79? I'll do it under the board here. If I have 2 to the 3x plus 1 equal to 1, I could take the natural log of 2 to the 3x plus, now that would be really silly. I shouldn't take natural. Let's take what? Log base what? Log base 2. Let's not be dumb. Log base 2 of 2 to the 3x plus 1 is equal to log base 2 of 1. But what is log base 2 of 1? What's log base anything of 1?
0.
0 is correct. So log base 2 of 1 is 0. And what's log base 2 of 2 to the 3x plus 1? It's just 3x plus 1, right? So the log base 2 and the exponentiation base 2, these are inverse functions.
Interesting.
And this gives us 3x plus 1 equals to 0. Which, of course, is exactly what I had up here. My bad. I was like, what? Oh, next problem. My bad. Up here, so 3x equals to minus 1. X is equal to minus 1/3. All right? Yes, Michael?
So is the log base going to be the greatest number or the lesser number?
The log base, I don't know what you mean.
So when you have the log base 2 of 2, 3x.
Use that so that you can get rid of the 2.
Oh, you're saying why did I do log base 2 instead of log base 3?
Yeah.
It's because we're doing 2 to the something. It's 2 to the something. If I had, instead of some,
If it is 2 to the expression, we put log base.
Whoa. It just came apart.
So as I was saying, if it has an exponent, we put the log in.
Yeah. So, Michael, like if I had 3 to the x squared equals to, 3 to the x squared plus 11 is equal to, I don't know, 1. If
Log base 3.
Yeah, log base 3 would be a good choice. The point is log base 3 and 3 to the stuff is an inverse function. So I just get that's equal to x squared plus 11, which of course would have been equal to 0. That one has no solution. This has no solution, see, because we get x squared is equal to minus 11. So no solution. No real solution, right?
No solution. Since all squares are positive.
All squares are non-negative, that's right. They could be 0. It could be 0. Okay, so then problem 80. This one's a little tricky because we've got the base 4 and we got the base 2, right? So I just traded a 4 for 2 squared, which makes everything powers of 2. And then we can use the 1-to-1 property. Or if you prefer, we could take log base 2 of both sides, yeah? So that gives me 2x is equal to minus 3x plus 1. I solve it, I get 1/5. Any questions? Okay, all right. Let's move along here. Problem 81. 100 is 10 squared, so 1-to-1 property for the 10 to the whatever power, the exponential base 10. I get x squared minus 7 equals to 2. X squared equal to 9, so x is plus or minus root 9, plus or minus root 3. There's you go. Now, of course, all of these problems we could have solved by taking the natural log of both sides if you'd prefer. Problem 82, square root of e to the x. That's really e to the x to the 1/2 power. So we can look at that as, e to the x over 2 equals to e to the 1 minus x. Now, once I have that, I can take the natural log of both sides. That gets me x over 2 equals to 1 minus x. And then, as usual, isolate your x and destroy them. And solve for x. X is equal to 2/3 in this case.
I thought we were destroying them.
Well, I decided to let it live. Live and let live. Yeah. I mean, if they're your x, then you're also their x. So you got to think about, you know, don't want to set a precedent for destruction.
So when
Yeah.
half plus 1 equals 1.5.
Half of 1 is 0.5, yeah. What's the question?
X over 2 plus x equals 1.5 of x.
Oh, 1.5 of x. Yes, that's also true. And 1 over 1.5 is also 2/3, or if you like, 0.6666666, but we try not to say that here. So, yeah. Oops. I added an extra 6 at least. So, and there's a point before it too. So, it's okay. Besides, some would say that has more to do with Nero anyway. But anyway, not for here. 2 to the log base 2 of 3 is, well, 3. Okay. I mean, that's true. What do you want me to tell me? I mean, do we agree?
Yeah.
Is this a mystery? I mean, this is essentially the definition of log base 2. Here, what I got to do is I bring the 2 inside to give me a 5 squared, and then I've got a 3 to the log base 3. Those are inverse functions. They basically cancel each other out and just leaves you with 5 squared, also known as 25. 8 is 2 to the 3rd power. So this is log base 2 of 2 to the 3rd power, which is 3. Here we have 1/27th. 1/27th is 1 over 3 to the 3rd power, also known as 3 to the minus 3. So minus 3. And of course, I suppose in your homework, or also on the test, if I was to ask one of these, can I really tell that you've used your calculator or not here? You probably could get away with using your calculator here. I mean, it would be hard for me to discern that you had used it. Right? Unless what? Unless you left me an answer that was like 2.99 or something. You know, if you had like, for whatever reason, your calculator gave you 2.99, they'd be like, aha, they used a calculator. But that's pretty much the only way I would know. And I think the calculators are better than that, so I don't know. To make this problem interesting for the test, I kind of almost have to make it symbolic. I have to make it have symbols in it, not just numbers. Otherwise, you guys just use your calculator, and that's not really what I'm trying to test necessarily. There's a symbolic problem later in mission, right? The A, B, C, D, and the 1, 2, that kind of thing. Let's see here. So 5,000, log 5,000 minus log 5 is the log of 5,000 over 5, which is the log of 1,000, which is the log of 10 to the 3rd power, which is 3. Because remember, log is the common log, it's base 10. Log base 10. This one looks kind of weird, but when you multiply 9 times 25, that gives you 3 times 5 times 3 times 5, also known as 15 squared, or 225. And so we've got log base 15 of 15 squared, which is just 2. And this one, part G, we've got e to the 3 times e to the 1/2, which is e to the 3.5. So, or if you like, you could write it as 7/2, I think, right? Or if you prefer 14/4, or if that doesn't do it for you, 28/8, or 56, well, I'll stop. Any questions? No? Okay. Here's the symbolic problems I was thirsting for. Natural log of A. This is hard to put in your calculator, right? At least in calculators I'm aware of, don't really do well with this kind of problem. Natural log of A minus natural log of B plus 2 times natural log of C. So I have division by B because it's subtraction. But on the other hand, the C gets powered up to C squared because of that 2 out front. So I get the AC squared, or if you like, natural log of AC squared over B. Now this one, I have a 2 outside the x. That makes this become an x squared. I've got the 1/2 outside the log of y plus 1. That makes it a square root of y plus 1. And I've got the subtraction of natural log z plus 1. That's why I have division of z plus 1 here. So I'm using the properties of the log to collapse the logarithm into a single log. Likewise, for the next problem, the 3 outside log of x puts a 3 x to the third power here. This 1/3 gives me the cube root, and the minus 3, oh no, oopsie, this is incorrect.
Oh, divide by 1,000.
Yeah, I need to divide by 1,000, don't I? So let me write that out over here.
Professor, just like you said, you have to think out of the box.
Think out of the box, yeah. I have to think, I guess, is what I'm getting to. Log of 3 log x plus 1/3 log of y plus 1 minus 3. Okay, so that is, I'll do a couple steps here. So this is the log of x cubed plus the log of y plus 1 to the 1/3 power, and then plus the log of 10 to the minus 3. You could do it like that if you wanted. You could leave the minus out. You could leave the minus out as well. Like either bring the minus in or leave the minus out in this step. I chose to bring it in. Let me write a little bit more here. And, okay, so then what? What's 10 to the minus 3?
Negative 1,000.
It's negative 1,000. No, well, kind of, but not quite that. 10 to the minus 3 is 1 over 10 to the third, right? Which is 1 over 1,000 is what this is here. So then that gives us log of x cubed times y plus 1 to the 1/3 times 1 over 1,000, which of course I can rewrite as the log of x cubed times the cube root of y plus 1 over 1,000, which is what I should have written here, but there's a typo here, obviously. Okay, it's just a mistake. It's just a mistake. I did not check my work. You're right. I'm checking it now, though. Right? Let's see here. Problem 87. Expand the expression and rewrite it in terms of a log x, b is log y, and c is log z. So I've got log of 100 xy squared z cubed. So I do log of 100 plus log of x plus 2 times the log of y plus 3 times the log of z. Everybody clear on where the 3 and the 2 came from? Does that make sense? Where those came from? The powers, right? Okay. And so, well, then that's literally 2 plus a plus 2b plus 3c. So, yeah. Let's see here. This one, we're supposed to expand and simplify if possible. So I'm starting with the natural log of x squared e to the minus x over the square root of x plus 3. So I do natural log of x squared plus the natural log of e to the minus x. And then I subtract the natural log of the denominator. So what happens? Well, the half pulls out. Natural log and the exponential are inverse functions, so that just leaves me with minus x, and the 2 pulls down like that. So that's about as simplified as I can do here, all right? Nothing you can do with natural log of x plus 3. Like, if you're thinking, oh, I can simplify that to like natural log of x plus natural log of 3, well, think again. That doesn't work. It's not true. Problem 89. What do we got here? Log base 3, a minus b. So what did I do? I first of all divided the 2 to the other side, all right? And then I brought that inside to give me a square root of c, all right? Then what I do, I took and I exponentiated both sides, base 3, so that gave me a minus b is equal to the square root of c, and then I solve for a. If you hadn't moved the 2 to the other side, it would have been much more annoying. Because what would have happened? I mean, it depends on how you did it, but if you brought the 2 inside, you'd have had like an a minus b quantity squared. And then you would have, it would have, this is just easier this way, all right? Now, I think this problem is potentially ambiguous without me giving you more information. Like probably I should have said something like, you know, assume A is greater than B or something like that. But anyway, it's probably better for this class to like just leave it slightly ambiguous and not tempt you to think about extra information you don't know quite what to do with. I have no regrets. I think it's a good problem, but if you were a math major, you might have some complaints for me, all right? I'm just saying. Hey, women, you guys are math majors, right? No. Oh, well. I try. So this one, just raise both sides to the 2 power. We get x minus 10 equals to 2 to the 5th, which is 32, so x is equal to 42. Hooray. This one, exponentiate both sides. We get 3x plus 2 equals to 1, which gives us x is equal to minus 1/3. What else we got here? Problem 92. Log of x plus 2 equals to 2. So I common log, so I use I exponentiate base 10, that's the natural enemy of it. They cancel out, inverse functions, get x plus 2 here. 10 squared, also known as 100, and so x is 98. Wasn't too bad. All right, next problem, log of x minus 2, graph it, find the domain and range. So the graph of the log of x minus 2 is basically just the standard graph of the logarithm shifted 2 units to the right. So it's got a vertical asymptote at 2, and it just kind of looks like this. Yes, Michael?
No. Just pointing out.
Oh, okay. Good. If we were to do more with this problem, what would the inverse function to this one be? Graphically, where would it be? Like the inverse function should have like a horizontal asymptote at 2, and it should be kind of like up there, right? Like flipped over the line y equals x. I guess we could find the formula for the inverse function. You want to do it? Well, let's go on. We did those already. Here's one. 2 to the minus x minus 3. So the way to think about the graph here is 2 to the x would look like the other way, like this, right? 2 to the x would look like this. So if we flip it, we get 2 to the minus x, which would look like that. And then we bring it down 3. And that gives us this. And there's supposed to be a space here, but sorry about that. So, but that's essentially it. That's it. This one here, find the formula for the inverse function again. So do you think there'll be a find the formula for the inverse function question on the test? I think there'll probably be a couple of them, right? More than likely. Let's see here. So y minus 3 over 2 equals to 2, equals to log base 3 of x minus 1. To solve for x, then, I have to take 3 to both sides. And that gives me 3 to the y minus 3 over 2 is equal to, well, x minus 1. Which then I solve for x, and I get this formula right here. 1 plus 3 to the y minus 3 over 2. There's the formula for the inverse function this time. Another. Here's another one of these. So here I have f of x is 3 to the 2, 3 plus 2 to the 3x minus 7. So again, I write y equals the formula, and then I solve for x. So to do that this time, I subtract 3 to the other side. That isolates my exponential function here. And then I use log base 2 on both sides to kill the exponential. So log base 2 of 2 to the 3x minus 7 is just 3x minus 7. And on the other side, of course, we have log base 2 of y minus 3. I add 7 to the other side. And then dividing by 3 gives me the formula for the inverse function. Right. Now what? Well, so we've had problems like this on the quiz, right? Almost exactly this problem as one of the ones I gave you guys in the quiz, right? So you're given this and supposed to graph the inverse function if possible. The answer was yes, it's possible because this passes the horizontal line test, right? So I just picked some representative points like 4, 8, minus 2, 4, and this guy down here was actually minus 6, minus 6. Whew, just stopped short. So that one just flips to itself. That's on the line y equals x, so it just stays put. And the minus 2, 4 flips to 4 minus 2, and the 4, 8 flips to 8, 4, and there's the inverse function. On the other hand, the upside down parabola fails the horizontal line test, and as such is not invertible. Problem 98. Here I have, this one's weird, right? I saw this problem like a couple semesters ago. I was like, what? I don't know how to solve this. Because it just like, what? It's like, how do you solve this? And then I was like, oh, duh. You just take x to both sides, and x to the log base x, of course, cancels and just gives you 3, and well, x squared is x squared, so then you can solve this plus or minus root 3. However, we do need for x to be positive because we do not want to think about negative bases. At least I don't. All right? So. I want to keep this class based and positive.
Is that supposed to be a dad joke?
What's that?
Is that supposed to be a dad joke?
Is that a dad joke? I'm a dad, so it's possible. What happened?
That one just says
I didn't hear you. I'm sorry.
Oh, I was just saying problem 100 is the only one that has 2 points. Right?
Oh, I don't know where that's left over from. I'm sorry about that. It must be something like that.
I was wondering when I was doing that.
It's just to make you wonder, I guess, and me as well. So anyway, we take the natural log of both sides and pull the x out, and that gives you x is equal to log 5 over log 2. That one wasn't too bad. This one, likewise, whenever you have different bases, you might as well just hit it with a natural log. It just works out, I think, nicest doing that. And so I get x log 3 over here. I get x minus 1 log 2 over there. I want to take everything with x and put it to one side. So that gives me x times log 3 minus log 2. And on the other side, I get minus log 2. Then we can divide by the coefficient for x, and that'll give it to us. Like so. And there are various ways of writing this answer. All right, if you have used like log base 2 or log base 3 to solve this problem, your answer will look different. It doesn't mean you're wrong, okay? There's like a dozen different ways to write this answer and still be correct. Don't worry, I'm grading it, so you'll be okay. Newton's law of cooling is always fun. So I weirdly have used y as the temperature and t as time. Mostly I did that just so I didn't have a big T and a little t, just to make it easier to discuss. So my model is y of t is 70 plus a times the exponential of minus kt. I know the 70 goes here because somewhere up in this paragraph I've told you room temperature is 70 degrees, right? Right here. So the room temperature is 70 degrees, so I put 70 there. I also know that the initial temperature of the coffee is 150, so that means y of 0 is 150. So 150 is 70 plus a times e to the 0, which makes a 80. At this point, I've figured out that the formula is 70 plus what? How did I get a 180 there?
I think you meant to put 80.
Goodness gracious, how did that? Well, anyway, I didn't mean it, right? I wrote this here, but I certainly didn't stick with that, did I? Because it's back to 80 down here, which is good because it should be 80. Sorry about that. What's that?
Another typo?
Yeah, take points away from me. It's good. You guys should take points away from me because I already have too many of your points. I'd like for you to take some of them back. Yeah. Please don't give me any of your points on the final. Nothing would make me happier than to just like grade 80 finals for my 2 sections this semester and just be like, oh man, just nothing but right answers. It's just so boring. This grading is like just stupid. Like everyone has all of the answers right. I would love to have to go to the dean and explain to him why I gave 100% A's in my 2 sections of college algebra. Nothing would make me happier than to have that conversation. I'd be like, I'm sorry, but they're just that good, you know? So, what can I tell you? It would not be me, because if it was me, then it should happen every semester. If that happens, it must be you, because before, in the past, there's a significant fraction that fail. So, anyway, that's not true. I'm just messing with you guys. It's a small fraction, but what is small? I went to class with this guy. His name was Dr. Martin. Yeah, I'm focusing. Dr. Martin, I'm gonna focus on this joke. So, Dr. Martin, he came into the class and Dr. Martin was a great guy. He was a real fun guy. And he come in the first day of class. He says, "They call me Square Root Martin." And we're like, "What?" He's like, "Yeah, I only passed the square root of the class." I was like, "Okay." Other semesters he'll go in and tell him he's Cube Root Martin, but anyway, he was actually very, very generous. Okay, I digress. Anyway, so we had an 80, and then we know that 120 is when we put in time 10. So that gives us this equation, which then solves to give you 50 over 80 equals e to the minus 10k. Taking the natural log gives us the natural log of 5 over 8 equals minus 10k. So I can solve that and get k is about 0.047. And then I put that in here. All right. And what's the final question is, at what time was it 80 degrees, right? So I got to plug in and I got to set y of t equal to 80 and see what that gives me. We did do an example like this in class, remember? Yeah. It took me like 15 minutes, didn't it? So we subtract 70 to the other side, it gives me 10, and I divide by 80. 10 over 80 is e to the minus 0.47t. Then I take the natural log of both sides, and then I solve for t, and eventually I get 44.24 minutes. So, yep. The usual question somebody asks after I go over this example is, are you really going to put that on the test? And the answer is, I really might. So, yeah.
The question is, why would you want to grade that?
Oh, I need something to separate the A's and the B's, so it's helpful. So here, this is a very, very reasonable test question. Suppose A of t is this, 5 plus 2 e to the minus 0.3t. Find the time at which A of t is 6. So all you gotta do is set the formula equal to 6 and solve for t. So we subtract 5 to the other side, divide by 2, and then the natural enemy of the exponential function is the natural log. So we take the natural log of that equation, we get natural log of a half is natural log of this, which is minus 0.3t, solve for t, and that's it. Now we have some of these fancy schmancy identity problems. Here, for every x, I want that to be true. So what I did is I took the natural log of both sides, and that gave me x log 2 is equal to kx log 3. And since it's true for all x, I could just put x equal to 1 and get rid of it. You could have put x equal to 1 at the start of this problem and solved it just the same, right? But anyway, after I do that, I get k is log 2 over log 3, right? Or if you like, you could say it's log base 3 of 2 by the change of base formula. Problem 104, kind of the same sort of problem. So I just do algebra here. I guess that's all we ever do, right? But 10 to the e to the minus 2t is equal to 10 to the 1/2 t over tau. And I divided by 10. And what else did I do here? I used a trick. I switched this to the log base to base 2 by my sneaky change to base 2 trick. And when I did that, that gave me 2 to the minus 2t log base 2 of e. And then I can use the 1-to-1 property to get this is equal to that. Divide both sides by t. I get t is equal to that. Rather, tau is equal to that. Which, anyway, gives me tau is log 2 over 2. Natural log of 2 over 2. That's one way you could do it. There are other ways. Let me go on here. How do you find the domain of a function involving natural log? Remember, we need the input to be positive. So here I'm solving 16 minus x squared positive. I've got critical numbers 4 and minus 4, and so I make my sign chart. And only between minus 4 and 4 are we good. We cannot include the endpoints. That would make us putting a 0 into natural log, which would be not good. This one, we need both x to be larger than 2 and x to be larger than 10. If it's larger than 10, it's automatically larger than 2, so that's the winner. Problem 107 is one of these quadratic ones. And problem 108 is a quadratic one. And I'm sorry, we seem to have run out of time. But I'll let you look at the solutions here. And do turn in your, I do need you to turn in the mission, so if you'd hand them over, that'd be good. Thank you. Sorry, I spent our precious solution time with my joke. I have no regrets. I have no regrets. See you guys Wednesday.